This is the video for arithmetic sequences in series. So an arithmetic sequence is the sequence that we talked about before where there was a common difference each time, right? So whatever that difference is, we're going to call it D. And so you'd have a sub 1, that'd be the first one, and then you'd have the second one, the second term would be the second term would be a sub 1 plus D, right? That would be a sub 2. And then we would add D again, so we would be adding 2 of them, so that would be a sub 3, right? And so on. So every time we're just adding one more. So this is just like the ones that we did in the first part, right? So a sub 1 is the first term because 1 is the first counting number, and that means it's in the first position, right? And so a sub 1 is the first term, and D is the difference. So we call it D for difference. Common difference means there's the same difference every time, right? You could find D by taking any term and subtracting its previous term. So in these sequences, let's find the common differences. If there isn't a common difference, then it won't be arithmetic, right? So we would just take 1 minus negative 2. So that's going to be 3. And 4 minus 1, that will be 3. And we could do any of them, right? So 10 minus 7, that's 3. So the common difference is 3. So now let's look at this one where I'm taking any term and subtracting the previous term. So subtracting a bigger number, so it's going to be negative. Negative 7. And sure enough, if we did 17 minus 24, we would have negative 7. And if we did 10 minus 17, that would be negative 7. So D is equal to negative 7. So you notice if it's a positive number, it's getting bigger. If it's a negative number, it's getting smaller. All right, so I want you to take a minute and decide whether or not these are arithmetic or not. So they're arithmetic if they have a common difference. So pause the video and see if you can tell whether they're arithmetic or not. And if they are arithmetic, tell me what D is equal to, what the common difference is equal to. Okay, hopefully you were able to see this first one is not arithmetic, right? Because if I do 9 minus 3, that's going to be 6. But if I do 27 minus 9, that's going to be 18. They're not the same. So this is not arithmetic. In this one, we have negative 8 minus negative 15. So a minus a negative is plus, right? So that's equal to 7. And negative 1 minus negative 8, that's going to be 7. And 6 minus negative 1, that's going to be 7. So it is arithmetic, and the common difference is 7. And you found here negative 8 minus negative 3 is going to be negative 5. Negative 13 minus negative 8 is also negative 5. And negative 18 minus negative 13, that is also negative 5. So yes, it's arithmetic, and D is negative 5. All right, so we want to be able to find the next terms when we have this sequence, right? So oftentimes maybe 3 terms is not really enough, but I'm going to tell you that they're arithmetic, and you find the next 2 terms. So how would we go about that? Well, we would be looking at the difference between these, right? So negative 14 minus negative 17 equals 3. We could double check. Negative 11 minus negative 14, so it would be plus 14. That's going to be 3 as well. So that common difference is 3. So my next term would be negative 11 plus 3, which would be negative 8. And negative 8 plus 3, which would be negative 5. Those would be the next 2 numbers in the sequence. All right, you try this one. Figure out the common difference and find the next 2 terms. Okay, hopefully you found that the common difference is negative 6. And that works for either time we do it. Negative 9 minus negative 3 is also negative 6. So each time I'm going to add negative 6. So negative 9 minus 6 would be negative 15. Negative 15 minus 6 would be negative 21. Okay, so now I ask this sort of problem. Find the 713th term of the arithmetic sequence. Oh. Okay, well, I could still find the difference. And I can see 4 minus 1 is 3, and 7 minus 4 is 3. 10 minus 7 is 3. I check those positive ones because they're easier to do in my head. But 1 minus a negative 2 is 3 as well, right? Okay, so D is 3. And I'm looking at the I want to look at a pattern. I don't want to keep adding 3, 700, and what would it be? 708 more times? I don't want to do that. And so I'm just going to look at a pattern, right? So that negative 2, that just came from the first term. And remember when we talked about how each term can be written as that first term plus however many times we've added D onto it. So let's think about that. We have the first term plus 0 D's. That would be the first term, negative 2. But the next term has to be the first term plus 3, 1, 3, right? And then I would take that term, negative 2 plus 3, and add another 3. So I'm adding on 2 3's this time, and that would give me 4. And when I got that 7, that was from negative 2 plus 3 3's, because that's how many times I've had to add D on. And that 10, the fifth term, is negative 2 plus 4 of those D's. So think about this in general terms. I have a sub 1 plus so many D's, right? Every time I'm looking at how many D's. So if I am talking about the a sub nth term, then what would go right in here for this question mark? What would go there? So can you see the pattern? Every time n is 5, that number of D's, the number we multiply by D, is 4. When n is 4, that number is 3. When n is 3, that number is 2. So if n is n, then what would go in here would be 1 less than n, right? So this would be n minus 1 in there. So that is our nth term arithmetic sequence. So often, remember in the last section, we talked about how you could come up with these nth terms, and we did that a little bit when we were trying to find some a sub n terms. But in any arithmetic sequence, you could write it like this. Now, that doesn't mean you would leave it like this. We might multiply it out and rearrange it, simplify it a little bit, but this is the equation that gets you to an a sub n for any arithmetic sequence. All you need is the first term and d, and you could find any term after that. Okay, so let's go back to our our sequence that we were trying to find the 713th terms. So what we want is a sub 713. So that's going to be a sub 1 plus, our common difference was 3, and we would multiply that by n minus 1, so that's going to be 712. Okay, oh, and I could have just put in, I know a sub 1, so I should just put it in here, right? All right, so first we have to do that multiplication, which can't do that one in my head. So 712 times 3, that's 2136. And then we have our negative 2. So that is going to equal 2134. All right, so this is the 713th term. And that's a lot easier than adding on 712 times. All right, so here's one for you to try. I want the a sub nth equation for this particular sequence. So look back at your notes there and tell me what that a sub nth formula would be for this particular one. Pause the video if you need to and figure that out. Okay, so a sub n, you remember from that screen a few screens ago, or it should be on your paper there. A sub n is equal to a sub 1, which is 18, plus d. Now, what is d here? The difference in each case, so I have, remember, 13 minus 18 would be negative 5, and 8 minus 13 would be negative 5. So d is negative 5, there's my d, times n minus 1. So we could simplify that a little bit. For sure, I could write just to subtract 5, but I could also simplify by multiplying through that parenthesis, right? So I would have negative 5n plus 5. And if I wrote that kind of in a more standard form, I'd have negative 5n plus 23. And that would be a simplified form of my a sub n formula for that equation. Now, it means that if I wanted to find the 100th term, I would just plug in 100 for n, and that would give me the 100th term. Here's another one. So write the formula for a sub n. Okay, so we need to know d. So that's going to be negative 1 minus negative 9. That's going to be 8. And if you just want to check, Well, 15 minus 7, there's another 8, so that looks good. And then we'll do a sub n equals a sub 1 plus 8 times n minus 1. And so we'll just simplify that. 8n minus 8, which is 8n minus 17. So in this one, we want to know a certain term. So we want to know the 15th term. And I know D and I know a sub 1. So pretty much what I'm looking for is the a sub n term. Only I can go ahead and plug in 15 for n. So I'm going to say a sub 15. So I got a sub 1, which is negative 2, plus d, which is 7, times n minus 1, and n is 15. So I have negative 2 plus 7 times 14, which I don't have that one. So 7 times 14 is 98. So that gives me 96. So a sub 15 is 96. So you see how we use that formula. So sometimes when we're doing it, we don't have, maybe we don't have the first term. But in an arithmetic sequence, it's always adding the same thing on. So if wherever you start, you can kind of just start there. It would still be a sequence. I would just have to kind of look at it shifted, right? So here's how, that probably didn't make any sense without showing you something, but here is the arithmetic sequence. If I don't know the first term, but I just know some term, right? So there is my some term in the middle. And here's how it's different is I'm subtracting k, whichever term that is, from n, not 1. Now it works with 1, right? So this is kind of a general formula. It will work with a sub 1, certainly. So let's see how that works. And this is one of those formulas that you want to make sure you have, right? Okay, so here's what we know. We have D is 6, so we know that. And the 86th term, is equal to 505. And we want to find the 33rd term. All right, so we're gonna use that formula, a sub n, which we're looking for a sub 33. So the one we know, a sub k, so we know that a sub k is 505, and we know that k is 86, right? So I've got 505 plus d, and then n minus k. Okay, so 33 minus 86 is negative 53. Times that by 6, and I get negative 318. And 505 minus 318. Oops, did the wrong one. gives me 187. All right, so that 187 is the 33rd term. Now, there are other ways to go about doing that. You know, we could take what we know and we could solve for a sub 1 and then we could go back in and plug it back in. But using this formula makes it a lot more straightforward. And this formula, if you know this formula, you can certainly, this is the one to know, right? Because it's general, it works for any term that you know. All right, so this one, I want you to try it. So pause the video and see if you can work it out. Find the value of the 74th term. Okay, hopefully you found it. We're looking for a sub 74. So n is 74. We know that the 36th term, so we know that a sub 36 is negative 286, and we know that k is 36, right? So a sub k, which is negative 286, plus we didn't have d. This was a little bit different, wasn't it? So it's a little bit different. So we're going to have to solve for d. All right, so what we know is d, and then we have 36, or sorry, which one? 74 minus 36. All right, so what we know now, we have that a sub 74 is negative 286 plus d which is 38. And we know that a sub 6 okay, I'm so sorry, but I don't want to redo this video. But I do want to solve for d, and I don't have any more space. So I'm going to erase this and start this problem over, because I'm not going to re-record this video. I'm going to use this and this just themselves in our equation to solve for d. So that means I've got a sub 36. A sub 36 is going to be equal a sub k, which will be a sub 6, plus d, and then we will do our n minus k, right? So we're going to do negative 286. That's my a sub 36. A sub 6 is negative 46. I don't know d, but I'll take 36 minus 6 is 30. So I have this equation, negative 286 equals negative 46 plus 30d. So if I add 46, so let's see, I need negative 286 plus 46 gives me negative 240, and then I'll divide by 30, which is negative 8. All right, so d is equal to negative 8. Okay, now I can plug in what I know. I'm looking for a sub 74. And let's just use a sub 6 for our a sub k. So I will have negative 46 plus d, which is negative 8, times 74, running out of room, minus 6. All right, so a sub 74, 74 minus 6 is going to be 68. And 68 times 8 is 544. So I have negative 46 minus 544. So that is negative 590. All right, so a sub 74 is equal to negative 590. It wasn't as bad as I made that look. Okay, so when we do the sums, remember we talked about sequences and we also talked about series. The sum of an arithmetic sequence works out really nicely because we have a good way to do it. All right, so let's just take a small set like the first 10 natural numbers. Okay, so there's the first 10 natural numbers. That's an arithmetic sequence, right? Where d is 1. And if we write that again backwards, right? It's the same thing. I've just rearranged them so they're going backwards and I add them. I'm going to have 2 of them, right? But every single time it's going to add up to the same thing. It's always going to add up to be the first term plus the last term. So it gives us the 11s. When we add them, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh yes, because I had 10 numbers, right? So I've got 10 times 11, but that was 2 of them, so then we have to divide it by 2. So 10 times 11, and then we divide it by 2. So here's the equation for that. Okay, so here's the first and the last, and we add them together. And we times them by how many terms there are, and then we divide that answer by 2. And that will give us the sum of any a finite arithmetic sequence, right? So this is an equation that you should write down somewhere, maybe on your note card for your final. Okay, so let's compute this sum below. We're going to do it in that formula, but the thing that we need to know what n is. Okay, so I can do my s sub n, I don't know how many there are, right? But I would take n times the first plus the last, so 8 plus 395 divided by 2. I need to know what n is, and I don't know what n is. But I can find out by using that same formula we did before, right? So if we have this formula here, here's our general formula with a sub 1, because we know a sub 1. And here's what it looks like, right? I know what a sub n is. A sub n is 395. And a sub 1 is 8. And d, did you figure out what d is from here? So from 8 to 11, that's 3. I just don't know what n is, but here I could solve for n. So I'll subtract 8 and have 387 and that will be, then I have 3 times n minus 1. I could divide by 3. So 387 divided by 3 gives me 129. And then I just have to add the 1. So n is equal to 130. And, all right, so that's what n is. So we just plug n into here. Okay, so I've got 130. And 395 plus 8 is going to be 403, and divide that by 2. Alright, so we have 130 times 403, and we'll divide that by 2, and that is going to be 26,195. Okay, you try this. This time, so is the same as before. We have to find out what n is, but you know d, and then we're going to find that sum. So try to do the very same thing that we just did. Find n, and then find the sum. Okay, hopefully you were able to find n. So first of all, we'll start with a sub n. This is our equation we're going to use. And what we know a sub 1 is negative 9. We know a sub n is 411. We know d is 3, right? So negative 6 minus negative 9 would be a plus 9, so that would be 3 and minus 1. All right, so we'll add 9. So I now have 420. Divide by 3. And that will be 140, and then we just will add the 1. So n is equal to 141. All right, so now we will have our sum. The sum of the first 141 terms will be, take our n, 141, add the first and the last. So I've got negative 9 plus 411. And we'll divide that by 2. So 141 times 402 divided by 2 is 28,341. All right, so sometimes we don't always write them as written out with the sum, but we can do it as a summation notation. So in this case, it's easy to find n because it's 29, right? We're going from 1 to 29, so n is equal to 29. So all I need to know is the first term and the last term, right? So my sum, 29 terms, I've got 29 times, so now I need the first term. So if I plug 1 in here, so a sub 1 is going to be 4 times 1 minus 1, so that would be 3, plus my 29th term, will be 4 times 29 minus 1. So that will be 116 minus 1, so that's going to be 115 over 2. And that will be 29 times 118. So 29 times 118 divided by 2 is 1,711. Alright, this is our last one, so I want you to try it. Do the same thing we just did in the previous one and see if you can find that sum. Okay, hopefully you remembered that n is equal to 312. So that was the easy part. So we need to find a sub 1, where I would plug in 1 here. So 3 minus 4 will be negative 1. And a sub 312 is where I plug in 312. So I got 3 times 312 minus 4. So 312 times 3 is 936 minus 4, which is 932. So my sum, and this is the 312th partial sum, right? So I've got n, which is 312, times the first one, which is negative 1, plus the last one, which is 932, over 2. So 312 times 931 over 2. 312 times 931, and we'll divide that by 2. So that will be 145,236. Okay, so those are arithmetic sequences. I will answer questions in the Zoom conference, and you should be able to do the homework from that. See you later.